Good afternoon, students. Welcome to one more amazing session from Infinity Learn by Sri Chaitanya. This is Suresh, Faculty of Chemistry. How are you, my dear students? Good afternoon. Can you all able to hear me? Can you all able to see me? Just give a confirmation in the chat box. Hello, Kifli. Right? Nice to see you guys on board. Right? So, welcome NEET STEP UP 2025 program on this YouTube platform Infinity Learn, offering physics, chemistry and biology sessions right from 1 o'clock to evening 6 o'clock. All the lessons and all the syllabus according to the NEET. So please attend these sessions regularly without any fail, and like the sessions and share with your friends. So इन लोगों को भी फायदा होना चाहिए, and subscribe to this NEET STEP UP 2025 program. And you all right now here with chemical equilibrium now. So when it comes to the NEET examination, I am Suresh, Faculty of Chemistry, and I am presenting you weekly 6 days without any fail, every day 1:30 to 3 o'clock chemistry sessions. First 3 days of a session, we are talking about 11th grade along with NEET concepts as well as multiple choice questions directly related to NEET examination. And next 3 days of a week we are trying to give you a 12th grade syllabus, and बीच में revision भी छोटा मोटा topics के लिए होगा, है ना? Hi, there what? I am Suresh, Faculty of Chemistry from Infinity Learn. Hello, Sudhanshu Yadav, good afternoon. Annamani, good afternoon. Devats, fine. And Kalmei Kifle Almeyu. Okay, anyways, so in this NEET platform, what Infinity Learn is doing, so you just don't believe it, but it is true. We did miracles in 2024 NEET examination, and the history goes on. And I just want to show you here many things over here. First, you see the toppers of the NEET examination that trained by the Infinity Learn, these 4 students you can see, Ashrita and Akhil Verma and Himadyuti and Satyanarayanan. They got the comparative picture. I just want to give you, it's a real numbers, and 310 marks in 2023, and she took a program from the Infinity Learn and she secured 661 marks, and you can see amazing 350 marks increment is seen. And also you see Akhil Verma, who got 313 just in 2023, but he secured 658 marks, 345 marks increment. And you can also see Himadyuti, and she got just again 310 in 2023, but in 2024 she got 652 marks, there is 342 marks increment. Just to see how strong the program is, 350 average you can take it. And Satyanarayanan, and 330 marks in 2023, he secured 650, and there is a 320 marks increment in this. And not only these 4, hundreds of students are there. Okay, hi Sony, central or state counseling registration fee alag ho, ना fee same ही होता है बेटा. And you can see you will be the next. I definitely promise you that you are following Infinity Learn lectures, and you will be getting the best for the NEET 2025. And what courses we offer on this? We are giving a NEET 2025 rank assurance program. In this NEET 2025 rank assurance program, I just want to show there is a huge pool of eminent faculties, and these are the salient features we can see. In the salient features we can see the 480 hours of live classes. You can see the downloadable notes is 5000 topic wise recorded videos is already available. You can scroll it up anytime, and chapter wise PYQs along with video solutions are available, my dear students. Full syllabus mock test, parent teacher meeting, 24/7 doubt removal sessions, and 30 NEET Achiever Series printed books आपके सामने आपके डोर स्टेप में मिल जाएगा. And with these salient features, you can see there are 9 students who secured 720 out of 720, and this is a genuine figure, and 41 students below 100 marks we got it, and 132 students secured 700 plus. You just see, you go to any premium medical colleges and majority of the students are from Infinity Learn by Sri Chaitanya. Definitely you will be the next for NEET 2025 rankers list. Agree? And also there is a restart program for NEET 2025 repeaters के लिए, and you can go through the coupon code Suresh 50. If you use that coupon code, you will be getting 20% of the fee concession based on that. How do you go there? I am going to show you in this lecture. You can see in the YouTube platform, in my live video, you can get my video on the description box. You can see my dear students on the description box. If you scroll down, you are going to see the first link. You are going to see, hi Hishita, you are going to see the first link, boost your NEET score with Infinity Learn and enroll now. You can simply click it on that. When you click it, the page is going to be directed to Earn Infinity Learn, and you can see all upcoming schedules and all the key features and the national level mock test, personalized learning experience, detailed study materials, and comprehensive video lectures, targeted practice questions. And these practice questions are very important, dear students, in NEET 2025. Sara, all the questions from the biology is from these books only, and chemistry and physics, not exactly the printed questions there, but replica of that questions are being seen. Believe it or not, you can see the previous year questions and solutions released by Infinity Learn by Sri Chaitanya, and also see the courses for higher score and better score. You are going to get various courses that are available on the same link, and you can click it on buy now, and you can be directed to verify your phone number, enter your phone number, and when you enter into your phone number, you will be directed to getting a payment gateway. Before that, you just go through that link, Suresh 50. Hi Kavian, Suresh 50 is my code. What is my code? Short marks में एक बार देना. Yes, and if you apply this Suresh 50, the tariff that is shown, the package cost, ये बहुत संस्था में कोई नहीं देंगे इतना सारा फीचर्स का. आपका 20% सीधा डिस्काउंट मिलेगा, and you can do the best for your NEET 2025. Are you ready for that? Ready for that? And once you are done with this, we can go into the lesson directly. And आज के लिए हम पेश कर रहा हूँ केमिकल इक्विलिब्रियम 11th स्टैंडर्ड का the last physical chemistry topic. Are you ready? Yes. Get it. Note down this coupon. You all clicked it once. Yes. Now we are going to enter into the chemical equilibrium. In this chemical equilibrium, the total part of the equilibrium is two types. One is a chemical equilibrium, another one is ionic equilibrium. Ionic equilibrium, I am going to present it for the next week, and this week first 3 days we are going to, first at least 2 days for we are going to do the chemical equilibrium. And this particular chemical equilibrium chapter, my dear students, it got one question from NEET examination undoubtedly, and also based on the applications of chemical equilibrium, you will be connected to thermodynamics. Their equilibrium constant versus Gibbs free energy, the relation is given, and is also connected to chemical kinetics and also connected to electrochemistry. So many things we have to connect to the chemical equilibrium with various chapters. So directly one question and indirectly और एक question पूछने का संभावना है बेटा. And yes, so Kavian ready, and Shawnlal, okay, Devarts, Ishita, Okay, Sudhanshu Yadav, many students are there in the line to start chemical equilibrium. So I'm going to present this chemical equilibrium right from the scratch level and up to the highest level, and you can see the pinnacle of the depth of the subject here. So the chemical equilibrium. So types of chemical reactions here. One is homogeneous reactions and heterogeneous reactions. So what is a homogeneous reactions? This is a chemical reaction. You can see nitrogen and hydrogen gives rise ammonia, and nitrogen is a gas, hydrogen is a gas, ammonia is a gas. So all the components in this are in the gas state. So all the components in the reactants and products are in the same phase are called homogeneous reactions. Yes, three younger sisters, Taj. Okay. And when you see heterogeneous reactions, in the heterogeneous reactions you can see zinc is a solid reacted with carbon dioxide, which is a gas, gives rise zinc oxide, which is a solid and a gas. So solid and a gas, two types of phases are seen in this reaction. So such type of reactions are called, more than one phase is there in this reaction, they are called heterogeneous reactions. So you are going to track into the homogeneous equilibrium and heterogeneous equilibrium based on that. Homogeneous means same physical phase or same physical state. Heterogeneous means different physical state or different physical phase, right? In that we will be going into the reversible and irreversible reactions. जो रिएक्शन है रिएक्टेंट प्रोडक्ट को दे सकते हैं, लेकिन प्रोडक्ट रिएक्टेंट फिर वापस नहीं बना सकते, दैट इज कॉल्ड irreversible reactions. Chemical reactions in which products cannot be converted back into the reactants, they are called as irreversible reactions. मान लो ये न्यूट्रलाइजेशन रिएक्शन में आपका मिलेगा प्रोडक्ट है ये सॉल्ट and in this you can say AgNO3 NaCl gives rise AgCl and NaNO3. So the reaction goes only in one direction, they don't come back into the backward, right? And also you can see the chemical reactions which are reversible, reactant product दे सकते हैं, product फिर वापस reactant दे सकते हैं. जैसे reactions कभी खत्म नहीं करेगा, है ना? These reactants never completely converted into the products, and here reactants are completely converted into the products. And reversible reactions generally not occur in the open container. Yes, I only teach chemistry, my dear student. Who may I know your name, please? Three younger sisters. All Indians are my brothers and sisters. Okay, so I want to know your actual name so that I can pronounce your name in the class. So this is an interactive live session on YouTube platform by Infinity Land by Sri Chaitanya. And yes, yeah, I'm going to talk continuously with the students by using the chart box that is displayed in front of me. Okay, Devats, are you there? Ishita, good afternoon बोल के silent रखे क्यों? Are you making a notes along with me, Ishita? Kaviyan? Okay, Anamani, had your lunch? After, yes, Taj. Your name is Taj. Oh, इतना खूबसूरत है. Okay, anyways, let us go ahead. And these reversible reactions forward भी दे सकते हैं and backward भी दे सकते हैं, लेकिन reversible reactions, irreversible reactions सिर्फ forward ही direction में जाना है. Okay, and let us go. What is the applications? What is the use of? We are in studying of these reversible reactions. Factors क्या? Yes, Spencer's. Abhinav is one student which is unknown, and this is Spencer's. I forgot your name again. So if you come every day, I can memorize your name. Okay, anyways, today the main course of the chemical equilibrium. I am fine, thank you. So the total physical chemistry. You people say that physical chemistry, जहाँ पर chemistry का क्वेश्चन में न्यूमेरिकल आएगा ना, ये physical chemistry आप ऐसे मानते हैं, लेकिन फिजिकल केमिस्ट्री का मतलब ऐसे नहीं बेटा. and physical chemistry is the one which is connected to the physical aspect. Chemistry is the study of chemical reactions. उसमें रिएक्टेंट्स प्रोडक्ट देते हैं. अगर ये रिएक्टेंट प्रोडक्ट दे सकते हैं नहीं दे सकते, रिएक्शन पॉसिबल है नहीं है, ये स्पॉन्टेनिटी के बारे में थर्मोडायनेमिक्स डिसाइड करते हैं. थर्मोडायनेमिक्स इज द वन फिजिकल केमिस्ट्री. अगर दे सकते हैं तो इतना जोर से रिएक्शन जाना है ना, एंड हाउ फास्ट द रिएक्शन गोस ऑन, and that is explained by chemical kinetics. And once the reactant is converted into the product, कितना reactant कितना product दे सकते हैं या product वापस कितना reactant दे सकते हैं, ये condition equilibrium होता है क्या. ये equilibrium में factors, what are the factors that influences that equilibrium, we have to study in the equilibrium. So thermodynamics, chemical kinetics and equilibrium, these are the core part of the physical chemistry, right? Have you been rice eating? Okay, everybody is rice eating, roti eating. I ate both today, right? Okay, come on, let's talk about the details about the equilibrium. In the details about the equilibrium, let us talk about what is active mass. Active mass is, yes, physical and physical chemistry are linked to each other, definitely. That's what I said. You say electrochemistry is also part of physical chemistry. Electrochemistry में क्या चीज इस्तेमाल करते हैं, तो रेडॉक्स इस्तेमाल करते हैं, इक्विलिब्रियम इस्तेमाल करते हैं, एंड गिब्स फ्री एनर्जी इस्तेमाल करते हैं. सिर्फ यही है. अंडरस्टैंड? देयर आर एप्लीकेशंस. ओके, talking about active mass, active mass is the term. Active mass means the concentration of the reactants and the product expressed in mole per liter or molarity or molar concentrations. Active mass is usually expressed by using a square bracket. You want to see A plus B gives rise to C plus D. Okay, in that A plus B gives rise to C plus D. So active mass of A मीन टू से स्क्वेयर ब्रैकेट में लगा के ये लिखना है. दैट्स व्हाट आई वांट टू से, है ना. या आई एम फ्रॉम हैदराबाद इन्फिनिटी लेन कॉर्पोरेट ऑफिस. आई टीच केमिस्ट्री हियर both online and the YouTube platform here. Taj, fine? You want to just come and join with the Infinity Learn app is there. There you can click and you can find us. Not only me, many eminent faculties on board, and you can choose whatever the course you can join. But whenever you want to choose, use Suresh 50 is a coupon code, so that you are going to get 20% of discount in the course, right? What is the course code? What is the course coupon code? Suresh 50, right? Taj, is that fine? Okay, let us talk about active mass is equal to number of moles upon volume in liters, that is equal to molarity, weight by gram molecular weight into 1000 upon volume in milliliters. So you can also take in partial pressures. The active mass only we use in equilibrium concepts. And let us talk about the active mass of solids, and this is very important. The active mass of the solids and the pure liquids at a constant quantity is taken as a unity, and solvent, if it is something excess, is taken and is considered as 1, because there is no change in activity with the change in quantity per volume of the vessel. So जहां पर आपका सॉलिड आता है ना, इसका मोल एक्टिव मास आप मान लो 1 है, and whenever the solvent is taken, in that case also you can take active mass as 1. This is very important. You can directly use this in NEET examination. Yes, whenever you just solve equilibrium problems, you take that particular thing into the consideration, then you never go wrong. It's very important. Yes. Now let us say molar concentration, that I already given. weight by molecular weight upon volume na. You can take this weight by volume as a density, density by molecular mass. This is also taken as an active mass. That's very important, or shortcut bhi hai. Okay, and also you can see density of the substance, molecular mass of the substance, and as density of the pure solids and liquids is constant and molecular mass is also constant, you can say, but this is not applicable to the substance in aqueous solutions or a gaseous state, because their amount in a given volume can change. It's a variable, but it's not constant. है ना? That's very important point. Dear students, let's talk about following other names of active masses can also be used, not only molar mass but also partial pressures. You can say mole per liter आप इस्तेमाल कर सकते हैं, आप ग्राम मोल पर लीटर भी इस्तेमाल कर सकते हैं, and gram molecule per liters you can use, and also molarity you can use, also concentration, any concentration term. I teach physical chemistry, not physics. Taj, I am taking physical chemistry, organic chemistry and inorganic chemistry, and we will be having Wednesday, Thursday, Friday, Saturday total organic chemistry ka, right? So all aspects of chemistry I am going to take. You just join with us and you can do the best, okay? And you can say effective concentrations you can take, and also active quantity you can take, N by V you can take, and C you can take. So many 9 versions of the active masses are taken, and also you can use pressures. 10 pressure is expressed in atm or bar or mm, hg, and many units you can use it, right? And we'll go into the application of law of mass actions, and when you use the law of mass action we can use only these active masses, right? And I just want to say 25.4 gram of iodine is present in only 2 liters of the vessel, okay? And you can see active mass of iodine is equal to 25.4 upon 254 is the molecular mass into 2 is equal to 0.05 mole per liter is the active mass. Got it? It's very simple, but students generally confused to understand how to find out the active mass. जो भी दिया ये active mass होगा नहीं होगा, and this is the best example. You can say directly what is active mass. And also 8.5 grams of ammonia is present in a vessel of 0.5 liters capacity. Then active mass of the ammonia is going to be 8.5. What is this 17? What is this 17, dear students? You tell me what is this 17? That is the molecular mass of ammonia, and into volume in liters, that is 0.5 is going to be 1 mole per liter. And also active mass of carbon solid or sulfur solid or zinc solid is equal to 1. Why? Because solid, जहाँ पर solid आता है ना, solid active mass is taken as 1. मान लो ये बहुत important चीज़ है, बहुत important चीज़ है. Are you all fine? Able to understand? Ishita there? Ishita, any doubt? Okay, Spencer, any doubt? Okay, Taj, Annamani, let's go ahead. And rate of a chemical reaction. Right from the chemical kinetics we have studied, and we are going to discuss about the rate and active masses, and also we will talk about the law of mass actions connected to that. So the change in concentration of the reactants of the products per mole in unit time is known as the rate of a reaction. We have average rate, we have differential rate, instantaneous rate. हाँ, यह फिजिक्स भी है, ये नीट चैनल में फिजिक्स भी है, शायद 4 बजे का आज शुरू होगा. ताज, आज फिजिक्स क्लास भी है मेरा क्लास के बाद. ओके बेटा. And also rate of a reaction is minus change in concentration of the reactant at the time is equal to minus dC by dt of the reactant. What is this negative sign here? Which indicates the decrease in the concentration of the reactant. ठीक है बेटा. And also here the negative sign indicates the concentration of the reactant decreases with time. We already learned this point in chemical kinetics in the previous week. If you want to see the session, recordings are available and you can watch in the recording channel, right? And also you can see the rate of the reaction with respect to the products. It is indicated the plus change in concentration of the products upon time and plus dC by dt and the products, and you can see what is the positive sign here. The positive sign indicates the increase in the rate, increase in the concentration. You can see concentration let a reactant A gives rise to B. So what happened as the time, concentration versus time, as time proceeds, concentration of the reactant decreases, and as time proceeds, concentration of the product increases. That you can say this is what you call the concentration of B. So there is a situation where the change in the concentration with respect to time do not vary. That state you can say equilibrium. That state you can say it is equilibrium. We are investigating the state of equilibrium in today's class. So this is about introduction. Let's talk about the concentration change may be positive or negative, but the rate of a reaction is always a positive quantity, my dear students. That's the reason why unit of the rate of reaction mole liter inverse time inverse. मान लो a time seconds होता है, so that mole liter inverse second inverse or mole liter inverse minute inverse mole liter inverse hour inverse, it all depends upon the time unit what you measure, right? And for an example, A gives rise to B. So with respect to the reactant, the rate of a reaction is equal to minus dA by dt with respect to the product, that is dB by dt. So the rate of the reaction should be equal here. So we can say 2A plus 3B gives rise C plus 4D. How do you write? How do you write this? Can be written as rate of disappearance of A is given as minus dA by dt. Rate of appearance of B can be written as minus dB by dt, and rate of appearance of C is given as dC by dt. Rate of appearance of D is given as d dt by dt, but they are equal according to the stoichiometric numbers over there. So that minus 1 by 2 dA by dt is equal to minus 1 by 3 dB by dt, that is equal to plus dC by dt, that is equal to plus 1 by 4 d by dt, that is given over here. So that's very good. Okay, you complete the chemistry lecture over here, and after chemistry lecture definitely upcoming physics and biology lectures are also available in the same channel, right? Okay, you stay here and you can see the rate of reaction is always for per mole, and if it is for A moles, B moles, C moles and D moles are there, with respect to that you can write this as जो भी stoichiometric number से ये fraction में लिखना है. That is a very simplified version of the rate of the reaction, my dear students. ठीक है? That's good. Okay. Now, for example, 2SO2 gas plus O2 gives rise to SO3. These are all just recapture. We learned these things in chemical kinetics, my dear students. And here, rate of reaction is equal to minus 1 by 2 dSO2 upon dt is equal to dO2 by dt is equal to 2.5 into 10 power minus 4 mole per liter. So that is equal to dSO2 by dt is equal to 5 into 10 to the power minus 4 mole per second. And also factors affecting the rate of a reaction. Very simple. State of matter पहला जो चीज है, the decrease in the order of the rate of reactions, gases को बिल्कुल ज़्यादा है, इससे liquid आना है, so gas greater than liquid, liquid is greater than solid. That is the first physical state of the matter. And also temperature, rate of a reaction हमेशा temperature में depend करते हैं. अगर temperature बढ़ते जाएंगे तो rate of the reaction भी increases. Okay, and also concentration rate of the reaction is directly proportional to concentration. रेट लॉ का हिसाब से रेट ऑफ ए रिएक्शन इज डायरेक्टली प्रोपोर्शनल टू कॉन्सेंट्रेशन टू द पावर n, वेयर n इज इक्वल टू ऑर्डर. अगर जीरो ऑर्डर होगा, फर्स्ट ऑर्डर होगा एंड सेकेंड ऑर्डर होगा. What day teaching this channel, and this channel I am teaching chemistry every day 1:30 to 3 o'clock. 90 मिनट्स का सेशन है. हर सेशन में एक टॉपिक आपका इतना एनर्जी का हर कॉन्सेप्ट आपका सामने एक्सप्लेन कर दूंगा, है ना बेटा. एंड ऑल्सो कैटलिस्ट, positive catalyst increases the rate of a reaction. Okay, so catalyst has no influence on the state of equilibrium. Catalyst has no influence on the reaction rate constant, but the speed of reaction can be altered by catalyst, right? And also chemical equilibrium. So फिलहाल आपका जो चाहिए fundamentally अब दिया हुआ, and I am going to explain chemical equilibrium. In that chemical equilibrium, the state of a reversible chemical reaction at which the rate of forward reaction becomes equal to the rate of backward reaction, that state what you call it as the state of chemical equilibrium. And you can see this graph, the rate versus time, and as the reaction proceeds, the rate of forward reaction decreases and rate of backward reaction increases. There is a situation where the rate of backward reaction is equal to rate of forward reaction. That situation is called as state of chemical equilibrium. This is what we need to study and how we have to do this. Main course for this entire chapter is this equilibrium state का कैसे पता कर सकते हैं, आपका अप्लीकेशन कैसे कर सकते हैं, है ना. कर सकते हैं, सब लोग कर सकते हैं, है ना. राइट, नाउ लेट्स टॉक अबाउट, लेट्स से ये मोल्स ऑफ ए प्लस बी मोल्स ऑफ बी गिव्स सी मोल्स ऑफ सी प्लस डी मोल्स ऑफ डी. इन दैट ये स्मॉल ए बी सी डी और देयर stoichiometric coefficients, and you can write rate constant is given as equilibrium constant, c to the power c, d to the power d, a to the power a and b to the power b. This is what you call it as equilibrium constant का expression. and जो चीज है स्क्वायर ब्रैकेट में ये एक्टिव मास का है, and I just want to show how we have to write this. And you can see writing equilibrium expression, you can see NH3 plus ammonia is oxidized to gives us NO2 and water. In that you can write equilibrium expression NO2 to the power 4, that is concentration coefficient of 4 NO2, and dot H2O to the power 6, so that it is H2O and 4 and 7 and 4 are given over here, right? So that is the actual representation of the rate constants over here. Are you able to understand? Yes. I do subscribe to the channel, but I am not present in this. Okay. So every day you present in my class, you will going to get an awesome lectures, right, Betam? Definitely you will be getting. Any doubt? Annamani, any doubt? Very good. I just want to promise you, if every day you join the class and follow my lectures and follow my tricks that I give you, follow my instructions I give you, follow my formulas that I give you, definitely you are going to crack NEET examination. Undoubtedly आप टॉपर भी बना सकते हैं, है ना. मैं आपको प्रॉमिस दे सकता हूं. आप भी प्रॉमिस का काम भी अभ्यास भी करना है एंड अच्छा तरफ एग्जामिनेशन लिखना है एंड रैंक पकड़ के जाना है. एंड डोंट फॉरगेट लाइक, शेयर एंड सब्सक्राइब दिस लेसन. Are you there with me so that we can start? Okay. Right. Thank you very much. Let's say Now at equilibrium state, characteristics of equilibrium, the rate of forward reaction is equal to the rate of backward reaction. यही है condition का है. And also at this state, equilibrium and forward and backward reactions proceed with the same speed. And also the state at the reversible reaction at which the concentration of the reactants and the products do not change with time at the equilibrium. And you can see the equilibrium state is perfectly thermodynamic in nature. I just want to say, if you want to say the water or any liquid and in a closed container. In the closed container, let us say liquid is evaporating, and when the liquid is evaporating and the evaporated liquid has to condense. So if you leave that, you don't see nothing is happening, but liquid is continuously evaporating, at the same time the vapor is continuously condensing. That state is what you call it as dynamic in nature. That is what you call it as dynamic in nature. Equilibrium is always dynamic, not static. And the reaction does not stop. Both the opposing reactions are going on continuously with the same speed. So you observe as if nothing is going on, but it is continuously आगे बढ़ रहे हैं, पीछे भी वापस आ रहे हैं. And also characteristics of chemical equilibrium, and this is very important. NEET examination में आपका सीधा पूछना संभावना है, which of the following is not true for equilibrium, which of the following is true for equilibrium. उसमें you are asked to find whether it is the correct one or false one. That's very important. Okay, let's talk about chemical equilibrium is dynamic in nature. It means that although appears to be stopped, but actually takes place in both directions with the same speed. And I am giving this, and in the Telegram channel सारे के सारा notes आपको PDF में मिलेगा, and you can do the best, right? And also to obtain equilibrium, if any one of the reactants or products in the gaseous state are, then reaction should be carried out in the closed vessel. Why closed vessel? Because if open vessel, if the gases are there, the gas can escape, so that we need to get the closed vessel. And also see, at a given temperature and the pressure, the equilibrium, the properties like concentrations, color and density, vapor density, and many things are going to be remains constant. Okay. And also in a reversible chemical reactions, the equilibrium state can be attained at lesser time by the use of a positive catalyst. But catalyst has no influence on the state of equilibrium. रेहन राजपुरा, हाँ क्लोज होना तो भी इवापोरेशन हो सकते हैं, इवापोरेशन पूरा के पूरा नहीं हो सकता है. मैं वो भी एक्सप्लेन कर रहा हूँ ना. take a vessel and you can see evaporation and condensation. That's the reason why when you open this and you can see the water droplets, you can see na Rehan Rajpura, right? Hope you understand. Clear? It should be closed. Then only evaporation equilibrium is observed. If it is open na, सारा के सारे evaporation जाके, and there will not be any liquid at the end. That's very good question, appreciated, right? And a catalyst doesn't change the equilibrium state because it increases the rate of both, मान लो, both forward reaction and backward reaction with the same speed. Okay. And equilibrium is achieved rapidly, but has no influence on the state of equilibrium, has no influence on the direction of equilibrium, has no influence on the equilibrium constant. What is the equilibrium constant? That we discussed in the previous slide, K, right? Now let us use the ethyl acetate, and hydrolysis in the presence of an acid gives rise acetic acid and ethanol. In this process you can use in order to prevent escape. Okay, that's a different matter. Homogeneous equilibrium, the equilibrium in which reactants and the products are in the same phase, liquid, liquid, liquid and liquid, है ना? So this is a homogeneous equilibrium. And also heterogeneous equilibrium, you can use different physical states, solid, gas, different physical states are seen. Understand? So let us check. So whenever a question doesn't ask about the direction, then we take a forward reaction only. This is a very good information. This is a very good information. आप NEET examination prepare कर रहा हो ना, so don't leave the given points and note. And in a reversible reaction, if forward reaction is exothermic, then backward reaction is going to be endothermic. So at equilibrium there is no heat loss, mind it. There is no heat exchange, mind it. If heat exchange is there, the direction of the reaction is going to be changed. And also types of equilibria, and you have physical equilibria and chemical equilibria. In the physical equilibria, you can see the change in the physical state of the same matter, but chemical constituents are going to be same. Only physical changes are seen. So you can see following types of common physical equilibrium can be seen: liquid vapor equilibrium, solid liquid equilibrium, solute solvent equilibrium. Yes, Jack Sparrow, you want me to laugh? Why? You laugh, then I laugh. We'll crack some jokes and make a laugh, right? Okay, lucky number guy. Now solute solvent equilibrium, gas solvent equilibrium. Okay, I laugh. Okay, so for what? Everybody, yes, everybody rise here with very good energetic classes, and finally we'll get a result. Then we'll have a laughter party. I am ready. Okay, now let's talk about the liquid vapor equilibrium. In a closed vessel, the vapors above the liquids are in the equilibrium at a given temperature. This is the liquid, it is evaporating. When evaporating, the evaporating molecule again condense back. So this is what you call liquid vapor equilibrium. So in this liquid vapor equilibrium, example H2O liquid and H2O gas, there is an interconversion between these. This is what at a dynamic liquid vapor equilibrium. Okay, I forgot your name, Jack Sparrow. Now one more solid liquid equilibrium. When you talk about ice in the water, if you keep ice over here and everything is kept in thermostat and maintain in a thermostat 0 degree centigrade, so ice is converted into water. Similarly, water is converted into ice. So this is what you call it as solid liquid equilibria. Okay, and also you can see solute solvent equilibria. For a saturated solution, you can see if the salt is added, this is a solution and the salt is added in large excess and stir it. So when you talk about sodium chloride is dissociated to gives rise sodium plus and Cl minus, and there is an equilibrium between these two, that is what you call it as solubility equilibria. And we are going to learn exclusively about this solubility equilibria in ionic equilibrium at the last topic. Okay, I am laughing at you. So what to laugh? I just give a small smile for your sake of blessings and you do the best. Okay, here we are all here to study, okay, and to rise and to develop, and not for spamming here. So precipitated foam, अरे हेनराज, precipitated foam अलग चीज है. Precipitated foam is in the form of colloidal state. Okay, that's not here. Okay, now let's talk about gas solvent equilibrium. When you talk about the gas solvent equilibrium, you can say this is a bottle. In this bottle you have water, and in this water, let us say carbon dioxide is a gas, and there is an equilibrium between the carbon dioxide gas and the water, that is called soda. That is explained by Henry's law. You can see when the pressure is increased, the solubility of the gas in the liquid is going to be increased. That is explained by Henry's law. In this Henry's law, you can say the pressure of the gas is equal to Henry's law constant dot mole fraction of the gas. As pressure increases, mole fraction increases. You can see at this pressure how much gas is dissolved. When the pressure is increased, the gas, that is, thank you very much, focus in the class. Okay, when the gas pressure is increased, more gas is dissolved in the liquid. So as the pressure increases, solubility of gas increases. It is connected to solutions and colligative property. शुरू में हेनरीज लॉ आता है ना. So ये concept का है, फिर भी ये connected to equilibrium, right? Let us talk about chemical equilibria. फिलहाल हम physical equilibria देख चुका, अभी chemical equilibria देखना है. And in this chemical equilibria, when chemical change occurs in the reversible reactions, the reactants are converted into products and the products are converted back into the reactants, so that you can see in the formation of ammonia as an example, formation of SO2Cl2, PCl5, and decomposition of ammonia. So there is always a reversibility in this reaction. So in these reactions, let us talk about what exactly the concept behind the study of equilibria. It is law of mass action. It is given by Goldberg and Wedge, and it says that the rate of a reaction is directly proportional to active mass of the reactant to the power their stoichiometric quotients. I just want to say, agar A gives rise to B, okay, rate of the reaction is directly proportional to active mass of A. Agar A plus B gives rise to C, rate of the reaction is directly proportional to active mass of A dot active mass of B. Agar you can say 2A plus B gives rise to C, you can say rate of the reaction is directly proportional to 2A, A square and B. We can write like this. Understand? Thank you. Very good. Now let's say A moles of A plus B moles of B gives rise to C moles of C. I just want to say rate of a reaction is directly proportional to A to the power A and B to the power B. है ना? Yes, it is. So many things you are going to learn from this law of mass action. You can say, consider this is a reactant, so that is a forward reaction, and C and gives rise to B, and this is what you call it as a backward reaction. So rate of forward reaction is directly proportional to A dot B active masses. Rate of backward reaction is given as C dot B active masses. So at the rate of formation, okay, and you can say, let us say here, rate of forward reaction is equal to rate constant of forward reaction dot A dot B. Similarly, rate of backward reaction is equal to rate constant of backward reaction C dot D. At equilibrium, rate constant of forward reaction, rate of forward reaction is directly is equal to rate of backward reaction. That's what I want to say here. Yes. Jack Sparrow, no spamming in the class. Please no spamming in the class. Now at equilibrium, I just want to say rate of forward reaction is equal to rate of backward reaction. Kf A dot B, that is the rate of forward reaction. Kb C dot D, that is the rate of backward reaction. So you take this constant, this is a constant, and this is a constant. So you can say constant by constant is going to be one more constant, that is called as a equilibrium constant. Kc is known as equilibrium constant. This equilibrium constant is of two types: equilibrium constant in terms of molar concentrations, equilibrium constant in terms of partial pressures. We are going to see the details and how to calculate all these things. Jack Sparrow, let us focus on the chemistry now. And many students, there are more than 500 students are there in the class. They are really wanted to focus on the concept. So please don't use the chat box as a spamming platform, and let us do the best for the NEET 2025 preparation. So बच्चे लोग इतना मेहनत कर रहे हैं ये कंपटीशन वर्ल्ड में, हमारा तरफ से फैकल्टीज इन्फिनिटी लर्न इज आल्सो डूइंग द बेस्ट, and you all just focus on the concepts that I am discussing here. So kindly please don't spam in the class. Fine, hope you understand. Now let's talk about Kc is the ratio. It is technically, this is Kc is the ratio of the rate constant and rate constant of forward reaction and rate constant of the backward reaction. So, and this is what you call it as law of chemical equilibrium. This is important. This is, we are going to discuss questions. After this we are going to discuss. Okay, it's okay. Thank you. Thank you for understanding, my dear students. So let's focus here. Let us say a stoichiometric equation: m1 moles of A, m2 moles of B, m3 moles of C, n1 moles of M, n2 moles of N, n3 moles of O. So in that case, for general reactions, Kc is given as MnO to their powers n1, n2, n3, and ABC to their powers m1, m2, m3. Are you getting or not? Don't you feel it's complicated? So I just want to say in simplified version, otherwise in simplified version, let us talk here A moles of A. मान लो ये reaction है, ये reaction है, A moles of A, B moles of B, reversibly gives us C moles of C and D moles of D. So the Kc is written as C moles of C and D power D and A power A and B power B. This is what is called as a Kc expression. Got it? Fine. That's good. And what is Kc and Kp? So Kc and Kp are same, but Kc is the rate constant in terms of reaction equilibrium constant in terms of molar concentrations, and Kp is the reaction molar concentrations you take in the active mass in the pressure. Same way you can say A moles of A plus B moles of B reversibly gives rise C moles of C and D moles of D. आपका कैसे बताता Kc you have, we already just C moles of C and D moles of D and A moles of A and B moles of B to the power B है ना. But yes, if it is क्या चाहिए? Okay, I forgot. Okay, माफी किया. Kp is equilibrium constant in terms of partial pressures. I just want to say Kp का expression यहाँ पर लिखना चाहता हूँ, so that you will understand when you take the active masses in terms of partial pressures, you can say Kp is equal to partial pressure of C to the power C dot partial pressure of D to the power D, partial pressure of A to the power A and partial pressure of B to the power B. है ना, एंड दोनों का रिलेशन क्या, that is also very important. Now we are slowly getting into how to write the equilibrium expressions. So the equilibrium expression says Kp is equal to Kc RT to the power delta n. आपका डेल्टा n कैसा निकलेगा, डेल्टा n is the number of moles of the gases, sum of the number of moles of the gases products minus sum of the number of moles of the gases reactants. So it is all depends upon the type of the reaction. Okay, okay, type of a reaction. If K डेल्टा n 0 होगा तो Kp Kc का बराबर होता है, डेल्टा n ग्रेटर देन 0 होना तो क्या होगा बोलो, इफ डेल्टा n इज इक्वल टू 0 देन Kp इज इक्वल टू Kc, अगर डेल्टा n ग्रेटर देन 0 होगा तो देन Kp Kc से ज़्यादा होगा, अगर डेल्टा n इज लेस देन 0 होगा तो देन Kp लेस देन Kc, है ना. These are the various points you need to take into the consideration to understand the proper questions in NEET examination. ये रिलेशन बहुत इम्पॉर्टेंट है, बहुत बहुत इम्पॉर्टेंट है. ओके, वेरी वेरी इम्पॉर्टेंट, राइट. R is a universal gas constant. R is a universal gas constant. ओके, सो Kp यूनिट्स का हिसाब से R वैल्यू लेना है 0.0821 लीटर इनवर्स लीटर मोल लीटर एटमॉस्फेयर. ओके, एंड इफ यू वांट टू से N2 is a gas, H2 is a gas, NH3 is a gas. Kc का एक्सप्रेशन कैसे कर सकते हैं, सो NH3 स्क्वेयर N2 एंड H2 क्यूब, है ना. यस और नो, क्लियर. अरे Kp कैसे लिख सकते हैं, partial pressure of NH3 square upon partial pressure of N2 into partial pressure of hydrogen cube, है ना. That's very simple. अरे डेल्टा n कैसे निकालना है, गैसेस है ना, सिर्फ गैसेस है ना. अरे गैस का डेल्टा n इज इक्वल टू 2 नंबर माइनस 1 प्लस 3 नंबर is going to be delta n is equal to -2. Got it? Got it? And Kc Kp का रिलेशन क्या दे सकते हैं, Kp is equal to Kc RT to the power -2, right? So अगर आपका Kc दे सकते हैं तो Kp निकाल सकते हैं, अगर Kp दे सकते हैं तो Kc निकाल सकते हैं. आर वैल्यू टी वैल्यू आपका बदलना, आर वैल्यू 0.0821 लेना, राइट. एंड और एक चीज है, क्या कर सकते हैं, PCl5 इसका Kc PCl3 एंड Cl2 अपॉन PCl5, Kp partial pressure of PCl3 into partial pressure of Cl2 upon partial pressure of PCl5. अरे डेल्टा n कैसे निकाल सकते हैं, जल्दी बोलो. After this 4-5 equations questions will come. Jack Sparrow, Taj. Delta n is equal to 1 plus 1 minus 1 is equal to plus 1. And I am going according to my own flow. Follow my flow, you are going to get the best questions out of it, right? And how to write this? All are in the gaseous phase. Kc is equal to C d to the power 4 a cube and b square. Kp is equal to partial pressure of C into partial pressure of D to the power 4 partial pressure of A cube partial pressure of B square, है ना? Yes, it is. And also follow very good examples. I just want to give you how to write the Kc expression for this. Very important example. Kc is written as KCl square O2 cube upon KClO3 square. But मैं क्या बोलना चाहता हूँ, this is taken as 1 and this is taken as 1. Why? Because you tell me why? Because जिस जहाँ पर सॉलिड आता है ना, सॉलिड का एक्टिव मास 1 लेना. सो इसका Kc एक्सप्रेशन आ जाएगा आपका Kc इज इक्वल टू O2 क्यूब, सिर्फ O2 क्यूब. दैट्स वेरी इंपॉर्टेंट. एंड Kp एक्सप्रेशन पार्शियल प्रेशर ऑफ O2 क्यूब. ठीक है? Yes, it is. I am going to give the questions after this, right? So let me tell you according to my own flow so that you can do the best out of any question. You can do it, right? So इसका कैसे लिख सकते हैं? Yeah, this is already completed. Now how to do this? Are so many controversies are there, but I don't want to put into controversies. Directly आपको दे सकता हूँ ethyl acetate. So CH3 COO C2H5 and along with water CH3 COOH and C2H5OH. बट उल्टा होगा तो वाटर इज टेकन इन लार्ज एक्सेस, तभी आपका प्रॉब्लम आ जाएगा. सो Kp इज इक्वल, इसका Kp एक्सप्रेशन लिखना 1 होगा, बिकॉज सब चीज है ना लिक्विड स्टेट है ना. एंड वन मोर हियर यू कैन से Kc is equal to NH4 plus and OH minus NH3 aqueous and H2O. Here water is taken in the large axis as a solvent. जहाँ पर solvent आता है ना इसका 1 होगा. So that I just want to say Kc is equal to NH4 plus and OH minus and NH3. फाइन. नेटवर्क प्रॉब्लम है, नेटवर्क ठीक चल रहे हैं. जस्ट गिव ए थम्स अप इज माय नेटवर्क इज फाइन फॉर यू. कैन यू एबल टू सी द लाइव स्ट्रीमिंग परफेक्टली? गिव ए थम्स अप, गिव ए थम्स अप इन द क्लास. इशिता, वेयर आर यू? Okay, everything is going fine. Your network is slow. How do you write this? Kc is equal to H2O. Kc is given as H2O and H2O liquid. है, ऐसा कैसे हो सकता है? हाँ, हो सकता है, लेकिन इसका गैस है, इसका लिक्विड है, अलग वैल्यूज होगा, अलग वैल्यूज होगा. एंड Kp सिर्फ पार्शियल प्रेशर ऑफ H2O बस, इज अ फिजिकल चेंज. पॉसिबल वैल्यूज 1, K is equal to 1, K is greater than 1 or less than 1. If you can say in the graphical way, rate and with respect to time, if the rate is given like this, so K is equal to 1. Okay. Now you can see if the rate is coming like this, forward reaction and backward reactions, okay, so it is going to be K is less than 1 but greater than 1 if it is coming like this, K is less than 1, okay. So as K value increases, the stability of the product increases, the stability of the reactant decreases, and the time to attain equilibrium decreases is very important, okay. Now stability of the reactants in the product, you can see there is a compound XO gives rise X2 plus O2 and rate constant K1 is given 1 into 10 power 24. So ये रिएक्शन हमेशा आगे बढ़ने का कोशिश करता है and XO2 gives us X2 plus O2, its K2 is given as 10 to the power 10 का है. So you can see this reaction, the K1 is lot greater than K2, है ना. So that what for reactant stability increases when the value of K decreases. For the product stability increases when the value of K increases. So K value पकड़ के stability of the reactant आप बोल सकते हैं, stability of product भी आप बोल सकते हैं, है ना. And more the value of equilibrium constant, more is the formation of the product, and also means more is the stability of the product. Are you able to understand? Now you can see. Now Jack Sparrow, for you a question. For you a question. Can you able to solve this question? फटाफट करके आंसर देना, फटाफट दे. जैक स्पैरो. As it is. Okay, let's solve here. Find the value of Kc for the each of the following equilibrium from the value of Kp. NOCl gives rise NO plus Cl2, Kp is given 1.8 into 10 power minus 12. So you can see here the answer. I just want to say in this NOCl, gives rise NO plus Cl2, Kp is given as 1.8 into 10 power minus 2, and delta N gas is equal to 2 plus 1 and minus 2 is going to be 3 minus 2 is equal to 1, Kp is equal to Kc, RT to the power delta N. So Kc is equal to Kp by RT 1.8 into 10 power minus 2 upon R value 0.0821 लेना के बोले में, and the temperature is given 600. On solving you are going to get 3.65 into 10 power minus 4. Fine. Okay, let's do here. And or a question है, find the value of Kc for the each of the following equilibrium from the value of Kp. Here Kp value आपको दे चुका 167 at 1173 Kelvin से. So Kc कैसा निकालना, Kc कैसा निकालना, it's easy to solve it. Copycat, hello, copycat. Okay, so Kp is equal to Kc to the RT to the power delta N. From there you can directly see Kp is given as 167 and delta N is equal to 1. Why? Because it is a gas, it is a solid one and it is a gas, so that it is equal to 1. Okay, and Kp is equal to Kc, RT to the power delta N, Kc is equal to RT, and here Kc is equal to Kp by RT, and Kp 167 and 0.0821 into 1173 is equal to 1.734. Okay, and also factors affecting equilibrium constant, mode of representation of the reactions. If this is given as A plus B gives rise to C plus D, Kc is going to be Cd upon Ab. If the reaction is reversed like this, so that C plus D gives us A plus B, and Kc dash is given as A B upon C and D. And what is the relation between this and this? ये उल्टा करके वो बना दिया ना, so Kc is equal to 1 by Kc dash, that is 1 by Kc dash. ठीक है, that's good, nice. Now और एक है, now for N2 plus 3H2 gives rise to NH3 if Kc is 5, okay, and a reverse करके then Kc dash for the reverse reaction, so इसका 1 by 5 करके 0.2 मिलेगा ना. It's very simple. And the stoichiometry of the reaction is given an important effect. When a reversible reaction can be written with the help of two more stoichiometric equation, the value of the equilibrium constant will be numerically equal to different. And I want to say for a reaction to NO2 gives rise N2 plus O2, Kc is given as N2 O2 square upon NO2 square. उसमें आप ये रिएक्शन डिवाइडेड बाय 2 करके NO2 रिवर्सिबली गिव्स रेस हाफ N2 प्लस O2, सो दैट Kc डैश आपका मिलेगा N2 टू दी पावर हाफ एंड O2 एंड अपॉन NO2. ये दोनों का रिलेशन क्या, अगर ये स्क्वायर करने तो ये मिलेगा ना, सो Kc डैश इज द स्क्वायर रूट ऑफ Kc. And this kind of interpretations are important for NEET examination. ये stoichiometry चीज का बारे में आपका एक क्वेश्चन आने का संभावना है, so everybody focus on this type of things, right? जैसे आपको मान लो SO2 plus O2 gives rise SO3, okay, so in that you can just double it and make it halve. In the same way you have to follow the pattern. And one more important thing, temperature, the value of the equilibrium constant changes with the change in the temperature, right? So मान लो equilibrium constant K1 अगर temperature T1 में है, equilibrium constant T2 temperature T2 का, so the relation between T1 and T2 and K2 and K1 they are given by the 1/2 equation, that is equal to log K2 by K1 is equal to minus delta H by 2.303 of 1 by T2 minus 1 by T1. This is what you call it as a 1/2 equation, and delta H is the enthalpy of the reaction, the heat lost or gained during the reaction. That is what you call it as here 1/2 equation. ये 1/2 equation का application क्या होगा, ये 1/2 की equation का अगर delta G मान लो, delta H मान लो 0, so neither heat is absorbed or evolved. So such kind of things, equilibrium constant remains the same at all temperature, so temperature has no effect on it. So thermoneutral reactions बोलना ऐसे, thermoneutral reactions. मान लो डेल्टा H 0 के ऊपर आने तो कम से कम आने दो, so let's say when delta H is positive, अगर डेल्टा H पॉजिटिव तो एंडोथर्मिक का हीट अंदर जाना, हीट रिएक्शन का अंदर जा रहे हैं, सो इफ हीट टेम्परेचर इज राइज्ड, रिएक्शन आगे बढ़ने का कोशिश करता है. log K2 minus log K1 is greater than 0, log K2 is greater than K1, so that if delta H is negative, that is called exothermic reactions. That exothermic reaction, heat is one of the product. So if the temperature is raised, the reaction आगे बढ़ना मुश्किल है, वापस आते हैं. So low temperatures favors these reactions. Like that you can do many type of things. The value of equilibrium constant is lower at high temperature. In the case of exothermic reactions, Kc is inversely proportional to T. ऐसे reactions का यहाँ पर Kc is directly proportional to T. So the value of equilibrium constant is independent on the following factors. हाँ रेगुलरली 1:30 से 3 o'clock तक. Yes, you want to come regularly, you come. Definitely you are always welcome. And NEET में ऐसे क्वेश्चंस, NEET में ऐसे क्वेश्चंस आता है कैसे, अरे बेटा which of the following is true, which of the following is not true, statement based questions. S1, S2, okay. So 4 options will be there. You know the model of the questions. We can see the value of the equilibrium constant is independent of the following factors. The first one is इनिशियल कॉन्सेंट्रेशन में डिपेंड करता है नहीं, लेकिन इक्विलिब्रियम कॉन्सेंट्रेशन में डिपेंड करता है. और द प्रेजेंस ऑफ ए कैटलिस्ट, मैं बोल चुका हूं कैटलिस्ट हैज नो इन्फ्लुएंस ऑन द स्टेट ऑफ इक्विलिब्रियम, rather catalyst is used to reach the equilibrium sooner, है ना. That's good, nice. And the direction from which the equilibrium has been attained, okay. मान लो ये एम्प्टी वेसल है, आप H2 एंड I2 प्रवेश कर दो, सो आपका H2 प्लस I2 गिव्स राइज HI. यह इक्विलिब्रियम असली का है. और एक मान लो एक्सपेरिमेंट 2 में ये एम्प्टी कंटेनर में HI इंट्रोड्यूस करो, H2 एंड I2 आपको फॉर्म होगा HI से, सो ये इक्विलिब्रियम भी होगा, ये दोनों में इक्विलिब्रियम स्टेट सेम होगा. एंड आल्सो प्रेजेंस ऑफ इनर्ट मटेरियल, मान लो इसके अंदर नियॉन गैस इस्तेमाल करो एंड कुछ नहीं होगा. अंडरस्टैंड. And also you can see many interpretations are there, 1 2 3 4, these 4 cases where the equilibrium state is not at all influenced. Hope you all understanding. And at the end of the session I just want to conclude this question. Catalyst only accelerate the reaction, and at the end of the session only one question I just want to say for this reaction EFGH. One start with 6.0 of E and 7.0 mole of F, and one in a 10 liter vessel. When the equilibrium is attained, 4.5 mole of G is formed, and calculate the value of equilibrium constant for the reaction. Are you ready to do that? Jack Sparrow, you only asked about this, right? Yes. You can do now? You want me to do? Get ready, set, let go. Okay. Anamani, so come on, let's see when EFGH gives the reaction here. Initially 6 moles of E is taken and 7 moles of G is taken, and at the end you have seen that 4.5 mole of G is formed, and जितना G form होए and उतना H form होना है, and that it is going to be 6 से 4.5 कमी कर दो, 1.5 बचेगा, एंड 7.7 से 4.5 कमी कर दो, सो सपरेट करने तो 2.5 मिलेगा. सो दैट यूज KC एक्सप्रेशन एंड 4.5, सो 1.0 लीटर है ना, 4.5 upon 1 upon 4.5 upon 1 एंड डिवाइड बाई 1.51 2.5. सो सब कैलकुलेट करके आपका इक्विलिब्रियम कांस्टेंट 5.4 मिल गया. सो दिस इज द एंड ऑफ दिस टुडेज क्लास. माय डियर स्टूडेंट्स, huge number of attendance I have seen in this. Don't leave these sessions, don't leave these sessions. You follow everyday session, you are going to get the best out of it. And I already shown you there is a link in the my live session. In my live session you have been given description box. In the description box at the end there is a link. You can click on the link, you will be directed to a page where you can see all the course related things. In this course related things you can click just buy now, and you are going to get yes Suresh 50 कूपन कोड एंटर मार के आपका 20% डिस्काउंट मिलेगा, है ना. है ना, मिलेगा ना? Yes. And today we had a great swell where we discussed all the concepts of equilibrium, and tomorrow we are going to discuss about applications of Kc, Kp, maximum number of numericals, and also we have seen and we will be seeing a Chatelier principle and many more things. Get ready for that. Signing off, Suresh, Faculty of Chemistry from Infinity Land. Stay back and like, share, subscribe this. Thank you very much. Bye bye.